Welcome, folks. So today we are going to talk about the Graviton challenge and how you can benefit from the Graviton2-based instances to get 40% better price performance on EC2. I'm Arthur Petit-Pierre. I'm an AWS Graviton Senior Specialist SA, and I will today guide you through the different steps of the Graviton challenge and the benefit you can get for your workload. So first thing, what is the 4-day Graviton challenge? So the 4-day Graviton challenge is a guided way that we defined and for which we wrote a white paper to help you with taking an existing workload and migrating it over to Graviton-based instances. So 4-day is a little bit of a catchy title. The idea is more that we will give you that white paper that's describing the steps to migrate an application. And if the application is simple enough, you can probably move that within 4 days. If you have something more complex, well, it's going to take a little bit longer, but the steps are going to stay the same, and the major ways to achieve that are going to stay the same. The URL for the challenge is displayed on the screen right now. You can go to it and enroll in the challenge and get the opportunity to win some swag. During the Graviton challenge, you will go through those 4 days of adoption. The first one, you will learn and explore. The second, you will plan your adoption, begin to set up an environment for it. On day 3, you will debug and optimize your application for Graviton. And on day 4, you will update your infrastructure and deploy your application. With that 4-day step-by-step plan, on top of that, you will get daily tips and tricks, and you will get access to Graviton Expert on our Slack channel. And at the end of the challenge, if you tell us what you did, you will get some swag. On top of the challenge, there's also the Graviton Challenge Context. This is limited to the customers in the US, and you get the ability, if you submit a description of your migration, you get the ability to win a trip to reInvent 2021. The submission, you can do the submission until the end of August, and the winners will be announced beginning of October. So first, what is Graviton? You probably already know about the EC2 instances that you can use on AWS. We have a huge portfolio with many different instances that are covering virtually every possible workload. The Graviton2 processor is the 2nd generation of our in-house designed processor. It's the 2nd generation after we released the Graviton processor that was powering the A1 instances, and that 2nd generation is way more powerful than the first one. So it's a custom piece of AWS silicon that is using the 64-bit ARM Neoverse cores, and we build it to target cloud-native workloads. The goal was really for us to build a processor that would be perfectly suited for the workloads that our customers are running in the cloud, and benefiting from their feedback to rapidly innovate, build, and implement newer generations of those processors. The Graviton2 processor was announced at reInvent in 2019, and it's powering the M6G, R6G, C6G, T4G, C6GN, and X2GD instances. All those instances are available right now. They offer up to 40% better price performance over the comparable x86 instances that we have in our portfolio. So for example, if you are comparing an M6G to an M5, let's take a M6G 4XL to an M5 4XL, the M6G is going to be 20% cheaper, and on most of the workloads, will provide you with more performance. The T4G is also an interesting family in our Graviton 2 portfolio. That's our first Graviton-based burstable instances. And the nice thing about it is that we have a free trial until the end of the year with the T4G instances. So they are the perfect vehicle to experiment with Graviton-based instances. We also recently released the X2GD. The X2GD is our instance with the highest amount of memory in the Graviton portfolio. It's also in the entire AWS portfolio, the instance with the lowest ratio of dollar per gigabyte of memory. So if you have any workload where you need a huge amount of memory, you will have up to 1 terabyte of memory in the X2GD instances with access to 64 Graviton cores. As I mentioned, all those instances are available right now. On some of them, you can also use one of the variants with local NVMe SSD-based storage. So that's the case for the M6GD, the C6GD, and the R6GD. And of course, the X2GD has local disks by default. We also have bare metal options on those instances, which means that thanks to the Nitro system, which is our virtualization stack, we can offer those instances without an hypervisor, and you get directly your operating system running on top of the processor without any hypervisor. That's pretty convenient when you need to either experiment with your own virtualization stack or do the kind of low-level profiling where you need to get access to all the performance counters. The Graviton2-based instances, or like most of our new instances, are based on the Nitro system. So of course, we use the Graviton2 processor, which is bringing those instances its amazing level of performance. We are using the Nitro security chip, which is integrated to the motherboard and protecting all the hardware resources. We use the Nitro cards with which we are emulating in the hardware all the devices that are made available to our virtual machines. And we use the Nitro hypervisor, which is a lightweight hypervisor running on top of the Nitro system that is providing bare metal-like performance to our virtual machines. Those super modular component are what allows AWS to rapidly iterate and release new instances like the Graviton2-based instances. With the Graviton2 powered instances, you get access to the highest performance in their instance family. They're 20% lower cost compared to same-sized comparable instances, and they are up to 40% better from a price performance standpoint. So let's talk a little bit about performance. When talking about performance in the CPU world, one of the first benchmark that vendors tend to run is the spec CPU benchmark. That's an industry standard benchmark, CPU intensive. And in that comparison, we've been running it on all the vCPUs concurrently. And then we compare the performance on a per vCPU basis. When comparing an M5 to an M6G with that benchmark, there are two sides. There's the integer performance and the floating point performance. On the integer performance, the M6G is performing 44% better than the M5. On the floating point side, we are doing 24% better than the equivalent Intel-based instance. Now let's talk a little bit about a something that is closer to a real application and no longer just a benchmark. So a use case where you're doing caching with Memcached. So the setup is the following. So on the left, we use load generators. And on the right, you have the blue box, the Memcached server, which is running on a Graviton-based instance or an x86-based instance. When we make that experiment, we were able to see 43% better throughput on the Graviton2-based instances compared to our M5 using an Intel processor. But the nice thing is that not only the throughput was better, but also the latency at scale was way better on the Graviton processor, showing the really good scalability of that processor under load. So not only you get the better performance, but on top of that, when you're pushing the system to higher levels of load, you even get better latency. Another thing that is important about the Graviton processor. So ARM cores are known to be quite power efficient. So we've measured the power efficiency of our R6G instances and compared that to our R5 instances. And when looking at the processor power efficiency, we were able to measure an up to 3.5 times better power efficiency on the R6G compared to the R5. And what a lower power consumption means is that we can increase the density in the data center. We can lower our costs and make those instances available at a lower price point for our customers. And we can lower the carbon footprint of our data centers. Let's talk a little bit about the different operating systems that you can run on Graviton-based instances. So as of today, you're going to be mainly able to run Linux or various open source Unices. There's not yet any support from Microsoft Windows on Graviton-based instances. On the Linux side, if you look at the landscape of the commercial distributions, you can, of course, use Amazon Linux too, for which we ensured that it got the best possible optimization level for Graviton-based instances. Red Hat is also an option, starting from Red Hat 8.2. SUSE with /15sp2 has good support for Graviton-based instances. And Ubuntu with version 18.04 and 20.04 has all the patches that are needed to ensure the best level of performance on Graviton-based instances. If you want to use open source distribution, CentOS is still an option, starting from version 8.2. Debian has good support for Graviton instances. You can use Fedora, and you can even use one of the open source Unices like FreeBSD or NetBSD. There's a wonderful community behind those operating systems, and they're perfectly supported. If you are running your workloads with containers, you have to know that the runtimes are perfectly supported with the ARM64 microarchitecture. Right from the beginning, there was support for Docker. Kubernetes in its vanilla version can also run on top of Graviton-based instances, and we have many customers doing it. And of course, the two AWS container orchestrators, Amazon ECS and Amazon EKS, are fully supporting the Graviton-based instances. At the container registry level, there's one feature that is really interesting when adopting the Graviton-based instances, which is the ability to use the multi-arch registries. So that's the ability to build container images for both architecture, x86 and ARM64, and upload them in the container registry under the same tag using a manifest file, which will put a pointer to an x86 version of the image and an ARM64 version of the image. And then at runtime, the runtime will be able to pull the right version depending on the underlying architecture. Bottle Rocket, which is AWS version of a container specialized operating system, is available for Graviton-based instances. And Firecracker, which is an open source implementation of micro VMs that we use among others for Lambda and for Fargate, is also available on Graviton-based instances. So what about the Graviton challenge? Let's dig a little bit into that. So here's the outline for the Graviton challenge. So I mentioned already, we divided it into 4 days and 2 steps per day, with a first initial step, which is to choose a workload. So let me help you a little bit with choosing a suitable workload for the challenge. So when we talk about migrating a workload to Graviton-based instances with customers, usually the simplest, the easiest way to adopt the Graviton-based instances is to adopt one of our managed services that is leveraging the Graviton2-based instances. So things like RDS, like Aurora, like Elasticache or Elasticsearch. Those services, they do require virtually no effort. There's almost nothing that you need to do. The only thing you need to do is ensure that your application is supporting the minimal version that you need on those services to be able to benefit from the Graviton-based instances. It's so easy that it does not qualify for the Graviton challenge. You need to work a little bit more for that. On the still super easy thing, there's EMR. It tends to typically just work unless you're using customized AMI, in which case you will have to port and reinstall the software that you are using. But otherwise, it's pretty straightforward. It just behaves the same way, apart from the fact that it can be faster and that it's cheaper. On the still quite easy workload, but now those one will qualify for the challenge. You have all the applications that are running on Linux and that are written in high-level languages. That's pretty easy. You probably have many of them in your portfolio. You just need to pick up an ARM64 AMI, install your dependencies and your application, and you're ready to test and run on top of those. Bonus, if you're using containers, that's going to be even easier. Another good opportunity for workload, slightly more involved this time, is to use an application running on top of Linux, but this time using one of the lower level languages. Things like C++, C, Go, Rust, that kind of stuff. Of course, for those ones, you will have to recompile because you need to target a different microarchitecture. It tends to be fairly easy, though, unless you're using intrinsics or handwritten assembly, in which case, of course, you will have to rewrite them to target the specific instruction of the ARM64 architecture. But in most of the cases, we've seen those workloads to actually be pretty portable, so they are a good target. Another workload that is also a really good target, slightly more involved, is if you have anything running on top of Microsoft Windows, leveraging the .NET framework. You have the ability to move those applications to that .NET Core to remove the dependencies with the Windows operating system and run that on Linux. And then once you're done with that first part of the migration, you can do a second part and move them to Graviton-based instances and benefit from the lower cost and the better performance. That's really a good opportunity where you can really modernize your application and win a lot from a cost perspective. Microsoft Windows-based workload, I'm sorry, that's not yet an option. We don't yet have that on Graviton-based instances. Okay, so now you've found a workload, a suitable one. First thing to do, learn a little bit more about Graviton and the overall ecosystem. We've recommended three things to learn more about Graviton. Two videos that we recorded at reInvent. One is talking specifically about the Graviton-based instances and is going to give you a couple hints about the different languages, which version to use, how to optimize. And the second one is a broader one about the journey to silicon innovation at AWS, where Ali Saidi explains why we are building custom silicon, the different areas at AWS where we design those custom silicon, and why it's bringing better performance at lower cost for our customers. And the last part that I would invite you to read is the Graviton Getting Started guide. So that's a guide that we are writing and making available on GitHub, and it contains lots of tips and tricks about the different languages, the runtimes, the operating systems, what software are available, what third-party vendors are available on Graviton-based instances, and lots of recommendation on how to configure your software to get the best possible performance from the Graviton-based instances. Once you're done with learning about Graviton-based instances and you have chosen a workload, the first step is going to be to identify your dependencies and their status. So it means looking at all the libraries, the agent that your application is using in production, all the libraries that are coming from either the language runtime or the various open source libraries that you're using to build your application. It can also be the ones that you're buying from third party, or the different security agents or logging agents that you're using when operating your workloads. For all of them, you will have to check that whether they have ARM64 support. And that can be a little bit tedious. Sometimes it means having a look to their GitHub repository, checking whether there are releases that are specific to the ARM architecture. Sometimes it means having a look to their bug tracking system to see if someone mentioned support for ARM64 at some point. If you're getting those software from a vendor, usually you can go to their website and check whether there's an ARM64 version of their artifacts. And if not, please let them know that you need such a version. And please potentially let us know. Tell us on Slack. There's a Slack channel coming with the Graviton challenge. Go to the Slack channel, ping us, and let us know that you need help to get a software vendor ported, or that there's an open source project that does not yet have support for Graviton-based instances and you would love to use them on Graviton. We can help with that. We have a team that is helping the open source projects and the software vendor to get their application ported to Graviton. So just let us know and we'll do our best to help you. Once you have the full list of your dependencies and you know where you are, you can start building an environment where you will be able to experiment with porting your application. One of the things you can do is start with an ARM64 AMI and deploy an EC2 instance with that AMI with the distribution of your choice. T4G instances are a good choice for that, as there's a free trial until the end of the year for those instances. So you can use them to experiment to create a golden AMI that would contain all your dependencies and allow you to get started with bootstrapping your application. If you're using containers, Docker BuildX is a good way to quickly experiment. It allows you to build an ARM64 specific version of your container in an emulated environment. So you can do that from your laptop. That's pretty easy to set up. It's a little slow to build because it's using an emulator, but it's pretty convenient because it's super straightforward. If you want something that would be more production ready, we have written, my good friend Tyler has written a blog post that is describing all the steps that are needed to set up a CI/CD environment using code build to generate containers for the ARM64 architecture and get that uploaded using the multi-architecture feature of ECR that I mentioned previously. That's a good option for a more production grade CI/CD pipeline that would generate images for two architectures. Another option is also to reconfigure your existing CI/CD pipeline if you already have one. If you are, for example, using Jenkins to build your artifacts, you can use it and deploy an agent running on an ARM64 Graviton-based instance and use them to build the ARM64 specific version of your artifacts. I really recommend going that way rather than using an emulated environment when you want to build stuff for Graviton-based instances, because building natively on Graviton-based instances is going to be easier, cheaper, and faster. So doing it with Buildix initially, that's convenient, that allows to experiment quickly. But as soon as you enter a more production grade step, well, definitely move to building stuff natively on Graviton-based instances. Okay, so now you're done with building an environment in which you can build stuff and install your application. So again, I mentioned that previously, but everything that would be using interpreted languages, byte compiled languages like Java should run mostly without modification. So it's just a matter of reinstalling all the dependencies and ensuring that all the versions are compatible and that all the dependencies are installed. Even .NET Core supports Linux, and it's pretty easy to install on ARM64, and you will get really good performance. Compiled application, of course, you will have to recompile them. The good point, though, is that all the major compilers have an ARM64 version now, or are able to generate ARM64 binaries out of the box. I'm thinking here, for example, about the Go compiler. You can generate the ARM64 binaries even from an x86 box, so it's pretty easy, and it runs well. For all of those languages, be it interpreted or compiled languages, as much as possible, try to use a recent enough version of either the compiler or the runtime. The more recent the version, usually the best performance experience you will get on Graviton-based instances. There are many patches that have been produced either by the open source community or by AWS or by ARM that have been integrated to those projects in the recent years. So if you are trying to adopt Graviton-based instances with an old version of a Linux distribution or a runtime, you may not get the best possible experience. So as much as possible, upgrade first, and then run with a recent enough version of your environment. Also, most of the AWS tools and SDKs, they do support the ARM architecture transparently. They run perfectly well on Graviton-based instances. So that's true obviously for the CLI, but that's true also for the various agents like the AWS CloudWatch agent. Once you're done with installing your application, Of course, changing architecture is a significant change, so you will need to test and debug your application, which means running all your test suites um, at the functional level, at the performance level, and ensuring that everything is behaving the way it used to behave on the previous architecture. From a performance standpoint, I already mentioned using recent enough versions of the various components. Another thing would be if you're recompiling anything, please ensure that you're using the right flags. Using flags specific for the Graviton-based instances can really improve the performance that you will get from your application. We've seen more than 20% for some application. Look also at the language-specific pages in the Getting Started guide. There are specific tips and tricks for various languages that you can use and apply, and probably something with which you're struggling is already listed there. If you still have a performance issue, you can have a look to the Getting Started guide and to the optimization page. We are guiding you into how to run a profile of your application to find the hotspots, and doing a comparison between a profile on x86 and a profile on ARM64 is going to be super helpful if you're asking us for support. If you have such an issue, please do those profiles and let us know, share with us the bottlenecks that you've seen, and we will help and try to optimize the corresponding parts. And now, once you have an application running at an acceptable level of performance, it's time to update your infrastructure to benefit from the Graviton-based instances. So from an infrastructure as code point of view, adding support for the Graviton-based instances is pretty straightforward. It's mainly updating your infrastructure as code, things like CloudFormation or Terraform, to include Graviton-based instances on top of the existing one. And in an environment like ECS or EKS, you can have both architecture running at the same time in the same cluster. So you mainly have to update the instance type, update the AMI ID, because of course you're not going to use the same AMI for the two architectures, and potentially update the user data to reflect some Graviton-specific features. And then once you're done updating the infrastructure as code, you can start deploy your production workload. Do it with a blue-green deployment method if you can afford it. That's going to allow you to check that everything is going well, check all the metrics, and do it gradually until the point where you're confident that you can migrate potentially everything over to Graviton-based instances. Monitor the error rates, monitor any unusual behavior so that you could be able to debug any unexpected new behavior on Graviton-based instances. And once you're done, definitely please let us know. Send us your feedback, send us your use cases, get the ability to win the Graviton Challenge context. We want to know more about it, and you will have the ability to potentially win a trip to reInvent 2021. So if you've not yet started, you can take the Graviton Challenge today and be done in a week with your first workload migrated. So I'm counting on you. Take the Graviton Challenge and let us know what you're doing with the Graviton-based instances. Thanks a lot for attending this session. If you have questions to ask, I'm on Twitter. You can ask question. You can send me emails. And if you need support during the Graviton Challenge, Join our Slack channel. We have Graviton experts from AWS connected. You can ask your question, share with us where you are on the Graviton journey, and we will help you as much as we can. Have a nice day. Bye.